So let us see questions of the type a cos x plus b sin x is equal to c. There are two different approaches for solving this type of questions. In one of the method, we can convert sin x and cos x in tan xy2 form. In another method, we will introduce one auxiliary argument. How to introduce that auxiliary argument? By dividing by under root of a square plus b square. So these are two approaches. Both methods I am explaining. So first method is convert cos x and sin x in tan xy2 form. Using the formula, write cos x is equal to 1 minus tan square xy2 upon 1 plus tan square xy2. And similarly we can use the sin x formula. Sin x is equal to tan xy2 upon 1 plus tan square xy2. These two formulas we can use for solving these problems. And then we will put tan xy2 is equal to t and we can solve. This will be quadratic in tan xy2. Second method is we will divide both sides by under root a square plus b square, where a is coefficient of cos x, b is coefficient of sin x. So divide both sides by under root of a square plus b square. Under root of a square plus b square. That means I can write this as a upon under root of a square plus b square cos x plus b upon under root of a square plus b square sin x is equal to c upon under root of a square plus b square. Now in this important thing is why we are dividing. What is the use of this division? The purpose is, if I consider a triangle like this, a right angle triangle. If this angle is some angle theta, then one I can take a, this can be, or this a as this b, depending on whether I want to convert this in cos form or sin form. For example, if I take cos alpha, this I will take a and this I will take b, and this will be under root of hypotenuse is under root of a square plus b square. So I can write this as cos alpha, this will become automatically sin alpha. So my question will convert in cos alpha cos x plus sin alpha sin x is equal to c upon under root of a square plus b square form. Now at the same time, if I am taking this as b and this as a, it will be sin alpha, this will be cos alpha. So I can change as per my options available. So I can write this equation as cos of x minus alpha is equal to c upon under root of a square plus b square. This step is very important for finding conditions on C. As my left hand side varies between -1 to +1, so right hand side also must vary between -1 to +1. That means this mod of this, so C upon under root of a square plus b square must be greater than -1, and this must be less than 1, then only some solution is possible, otherwise cos alpha will not exist, cos theta will not exist. So from here we can say that this C, mod of C must be less than or equal to under root of a square plus b square, or in another words I can say that this equation will have root if and only if, under one condition only, this equation will have root if and only if this equation will have real solutions if and only if mod C is less than equal to under root of a square plus b square. This is very important condition. If this condition is not fulfilled, there will be no root of this equation. This equation will not have any real root. So sometimes there will be some questions based on this concept only. So this is very important. You must note down this carefully. This equation will have real solutions if and only if mod C is less than or equal to under root of a square plus b square. And then afterward we can find solution by our normal method. One example I am taking to explain all this concept. Let us take one question. Solve under root 3 cos x minus sin x is equal to 1 upon 1 is equal to 1 or is equal to under root 2. Suppose this equation I have to solve. Under root 3 sin x cos x minus sin x is equal to under root 2. I am explaining by the second method. So here if you observe here a is equal to under root 3, b is equal to 1 and c is equal to under root 2. So under root of a square plus b square is how much? Under root of a square plus b square is equal to 2. 3 plus 1, 4, under root 4 is 2. So divide this equation by 2. We will get under root 3 upon 2 cos x minus 1 upon 2 sin x is equal to under root 2 upon 2 is 1 upon under root 2. Now this quantity I can convert in sine form, I can convert in cos form, it depends. In this particular case I have converted in cos form. If you want you can convert in sine form also. But if choice is available, we must convert in cos form because solution of cos is bit pleasant. That means when I solve cos x equal to cos alpha, my answer is x equal to 2n pi plus minus alpha. Whereas in sine, answers are bit n pi plus minus 1 raised to power n into alpha. So that looks weird. Although I will explain how you can have in multiple option correct questions different answers of the same. So here again approach 1a, first approach. I can write under root 3 by 2 as cos pi by 6. This is sin pi by 6. So I can write cos pi by 6 cos x minus sin pi by 6 sin x is equal to, this will be cos, so cos pi by 4. So this we can write as cos a cos b minus sin a sin b is cos a plus b, x plus pi by 6 is equal to cos pi by 4. So from here you will get x plus pi by 6 is equal to 2n pi plus minus pi by 4. You can solve this two parts. So you can write x is equal to one solution 2n pi plus pi by 4 minus pi by 6 and x equal to 2n pi minus pi by 4 minus pi by 6. So from here you will get x is equal to 2n pi, take 12, 3 minus 2. So plus 3 pi minus 2 pi, pi by 12 will be left. This is one solution of this. If you take 12 LCM, 3 pi minus 6 into 2 pi, 3 pi minus 2 pi is pi by 12. Another solution you will get from here, that will be 2n pi, now in this case minus 5 pi by 12, because in this case they will be added. So these are two solutions of this equation if we solve by this method. Now both methods are correct. There is one more method of solving this, B option. Here I am writing B option. Particularly it is problematic when you are solving multi-option correct or objective questions. You have solved by this method, but answer may be given in some other form. For example, here under root 3 by 2, I can write sin pi by 3 is also under root 3 by 2, cos pi by 6 is also under root 3 by 2 into cos x minus cos pi by 3 sin x is equal to sin pi by 4. In this form also I can write. So this is in the form of sin pi by 3 minus x, sin a cos b minus cos a sin b is equal to this, is equal to sin pi by 4. So I can write pi by 3 minus x is equal to n pi plus minus 1 raised to power n into pi by 4. You can transfer all the terms to this side. This will give me another answer. So x is equal to pi by 3 minus n pi minus 1 raised to power n into pi by 4. As n is integer, so writing minus n or plus n doesn't matter, because we will be taking n as 0 plus minus 1 plus minus 2 everything. So this can be written as, same thing can be written as minus 1 raised to power n in this form. You can convert all this in minus, so pi you can take outside and minus n you can take, because n is integer. Even integer, odd integer, that will matter. So you can write here n pi plus pi by 3 minus minus 1 raised to power n into pi by 4. Both will give same answer. The answer for minus 1 will be same as here plus 1. You can see in looks both are looking different, but if you take two cases there, n is even, n is odd, you will get same answers. So look wise they will be different. If in objective questions you see this is of this form, my choices are of this form minus 1 raised to power n, that means immediately this idea must strike in your mind. He has converted the question in sin x form. If answer is in terms of 2n pi, that means he has converted question in cos x form. So in one question of this question, all four choices may be present and all four are correct.